Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes.
This video is sponsored by Taggetize, the easiest way to run tag all on multiple Revit views and sheets. Also, say goodbye to overlapping tags. Taggetize will turn this into this. Try Taggetize completely for free using the link in this video's description. Today, let's do some freeform modeling in Dynamo. I'll show you how to generate this type of design yourself. It can be a facade, a feature wall, or some fancy fence, entirely up to you. The script we create will be fully parametric, so you can adjust the size, thickness, and openness of all louvers in this system.
If you don't have much time and just want to run this script right away, simply find in the video's description a link to download this script directly. If you, however, want to learn to code this yourself, let me show you how right now, step by step. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's begin.
First thing first, let's create a conceptual mask family to define our form. Make sure to select the right family template for the mask. Once inside the family editor, let's open the plan view. I'll draw now a quick circle of a radius of 15 meters. This is just to get a better sense of scale in 3D later. Next, I can start drawing a spline by control points. I will place more points along the straight segment to make sure it's as straight as possible. I can also move those points after placement to make the transition from the curve to the straight sections smoother. What I can do next is turn this spline from a normal model line into a reference line. We can do that easily by checking this box here under the Lines Properties section. Next, I'll create a new level by copying the default one up by a few meters. This then allows me to copy my spline to this new level using the Paste Aligned command. Moving on, I will also copy the reference lines forward to create a new set of splines that I'll use to create the undulating surfaces. Let's copy this new reference line to the upper level as well, just like before. This is where I can start creating some surfaces. I'll start with the one at the back of the mass. Then, let's return to our reference lines at the front. I'll copy them up a few times to create 3 reference lines here in total. Now, to make this surface appear more interesting, let's start adjusting the control points of our reference lines. You can be more creative, but for now, I'll just add some small position differences to achieve a rough waving effect. Now, to actually create the surfaces, we can simply select those lines in pairs. With each pair selected, I can click Create Form to make a loft surface spanning from one line to the next. Repeat this a few times, and there we have the conceptual mass done. Actually, you know what? Let me also create a base surface for this mass. This will become handy in a minute. Simply create an extrusion and then delete the top surface of the solid form, and voila, we only get the base surface left. Anyway, this mask doesn't look particularly pretty. Therefore, I'll use this other conceptual mask family that I modeled in a previous tutorial instead. It was created using exactly the same method. I just spent more time tweaking the reference lines in this one, so it looks much better. Feel free to use your own Revit mask if you want to use mine. However, just download it using a link in the video description. Before switching to Dynamo, a quick shout out to our sponsor, Taggetize. With Taggetize, it's never been easier to tag multiple Revit categories at once using your favorite tagging styles. Say goodbye to spending countless hours untangling Revit tags. After running Taggetize on this view, for example, all my tags are perfectly readable. None of them overlaps with their hosts or other elements in the view. If I think this tag, for example, can be placed better, I can just select it and click Next to tell Taggetize to try the next possible tag position. Each time I click the button, Taggetize moves the tag for me, and I can keep doing this until it gets to a tag position I like. There we go. That's much better. Try Taggetize completely for free today using the link in this video's description. I will now open Dynamo and create a new script. The first thing we need to do is import the necessary mask surfaces from Revit. Let's add a few select face nodes to do that. I'll add 4 of those here because we need to select the 4 wavy surfaces from the front of my mask. Now for each select face node, I can click and pick one surface from my wavy mask like this. Next, I'll put all 4 faces on the same list and then flatten it. Flattening the list will allow me to manipulate it easily in the upcoming steps, which will involve lots of geometry handling. The goal is to join those into a single surface. I can do exactly that using a surface by union node. It takes in all four faces and merges them all into one. As you can see, we have in this list 4 separate surfaces. Now, using the union node, we can quickly merge them into one. Great. Let's now start slicing the surface to create our louvers. To do that, we'll need to add a select edge node here, and then use it to pick this edge from my mass. Next, I'll attempt to extract from this edge a series of points at regular intervals. For example, 1 point every 300 millimeters along this edge until the whole edge is covered. The node to do that is curve point at segment length. However, this node requires a list of segment lengths. I'll generate these length values using another node called range. This node will give us a series of numbers between the start and end values. Each number will be greater than the value that comes before it by this step value. I'll start with a step value of 300 millimeters, but feel free to pick another value that works for you. The start value is 0, which is fine. However, I'll need to get the end value from the edge. This should be the total edge length because we intend to sample points along the entire edge. That's easy enough. I'll just need this curve length node to get the end value, which is the total length of the edge we picked, and then hook it up to the range node. With all that's in place, I can now run the point at segment length node. There's a warning now about geometry scaling. I can easily resolve this warning by clicking this button and setting the value to large. I can then rerun the script to refresh the output. There we go. Now all the points I need are there. Next, we need to slide the surface using some cut planes. I'll create one cut plane at each point we have sampled. To do that, let's drop in here a new plane by origin normal node. The plane origins will be the points we generated. The normal vector of these planes will be the same, but it can be either the global x or y vector in our case. I'll try the x vector first, and if that doesn't work, the y vector will do. Oh great, it works the first time. Now I have lots of cut planes ready to act on the joint surface. To slice it, we can use the geometry intersect node. This takes in the surface geometry and also takes the cut planes from the other input port. The geometry to be cut will be, of course, the joint surface we created earlier from the 4 faces and the front of my mass. There we go. You can see the slicing operation has worked. We now have a series of intersection lines on the surface, ready to be turned into 3D slats. However, here's a caveat. If a plane doesn't intersect the surface, it will produce an empty list here. We need to remove those lists or they will cause issues in the next step. To clean them up, I can query each sublist to see if it's empty like this. Make sure to enable use levels on this node if necessary. Then, I can use a filter by Boolean mask to separate empty lists from populated ones. The empty ones can be ignored. The lists that contain at least one curve are valid and can be used for the next step. I can then safely feed valid lists to the next node called polycurve by joint curves. This ensures that for each cut plane, I'll only have one intersection polycurve on the surface. Now it's time to turn those polycurves into proper surfaces. To do that, I'll drop in here a curve offset node, connect it to the list of joint polycurves, and give it an offset distance of maybe 250 millimeters. Let's quickly rerun the script to see what will happen. Very nice. Now all the polycurves have been offset to create a second set of curves. Then I can duplicate these 2 nodes to offset the same curve in the other direction. For this inverse offset, I simply need to change the distance from plus to minus and it has worked. With that done, we can now create a new list from the 2 lists of offset curves. I can then call the list transpose node to transform the list into a series of sublists. Each sublist contains 2 curves created from offsetting the same intersection polyline. What that means is I can now add and use a surface by loft node to create a new surface for each pair of offset curves. Before doing that though, let me just quickly turn off the geometry preview of all previous nodes in our script. This is to make the new loft surfaces appear more clearly. Now I'm sure you've guessed what we'll do next. Let's just convert each surface here into a solid using a surface thicken node. Let's connect the loft surfaces to this new node first. I'll use an extrusion depth of 150 millimeters here. Just like with any other numeric input in this script, feel free to adjust this to suit your project. And voila, we now have a beautiful set of 3D louvers. Now that's all well and good, but the geometry currently only exists in Dynamo. Let's bring this into the Revit project. We can simply connect the list of solids to a new import instance by geometries node. This node will actually create the solids in the Revit model. This process can take a bit of time, depending on the number of solids and their complexity, so please be patient. With that done, we now have the real 3D objects in the model ready for documentation. I'll just quickly turn off the blue geometry preview of Dynamo and Revit so that we can see the new object more clearly. I personally like to turn off the mask and enable hidden lines mode for the view to see the result better. As a bonus, you can also set the material for this import instance. Just to go Manage and select Object Styles. Under the Imported Objects tab, find the new instance we imported, and then set its material using the button at the end of its row. I'll do it for its sublayer too, just to be thorough. Of course, the material color doesn't show in hidden line mode, so let me turn on shading again for this view. And there you have it, the fully parametric facade with your own custom materials. There's also a link in the description to download the script we built together today. Even more, if you want to master Python scripting in Dynamo to create this kind of script yourself, check out my full online Python for Dynamo course, also linked to in the video description. Before you go, check out our sponsor, Taggetize. Save all your tagging styles in one place and tag one or several views or sheets at once. Also, say goodbye to overlapping tags. Simply review generated tags and make any final tweaks with the handy tag audit commands. Try Taggetize completely for free using the link in this video's description.
If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.